Are there any residual questions on the exception handling? Or you seen enough of that for a while and ready to move on?
I'm paranoid. Just because I'm paranoid, I think I know which methods were we not supposed to touch. Or we're giving that exception.
I guess I need to look at it. I don't think there's anything to be done in the default constructor. This one we talked about, which is you have to deal with the assignment operator inside of this copy constructor. Nothing to do in the destructor, or as the 111 students like to call it, the deconstructor. Definitely need to do work on the assignment operator, which I hope is obvious since we talked about that the first time we dug into this. Definitely need to deal with push. You need to deal with the pat return by value and pop. Nothing to do in size. That's it. All right. So let's look at this project. This project is for us to get into the internals of output streams, the O stream. And so we'll spend time looking at online documentation and ferreting out how we can customize output streams to do our own specialized output. An aspect of that is reflected in what we've learned about interfaces and inheritance. By interfaces, I guess I mean the public portion of a class, or protected, either public or protected portion of a class, and inheritance. To get more specific, we are dealing with inheritance in the library project, and in the library project, some function, in looking at media specifically, some functions were virtual, some weren't. If an application programmer was to come back to the library project with the requirement that they needed to add another media type to the library, let's see, can't even venture to guess what that type might be. DVD? I don't know. Some additional media type that needed to be supported, then they would derive their own class off of media. And so the way you designed the media type is you had certain intentions to happen with classes deriving, and well, let me just leave it at that. So I guess I'm kind of skipping around. I'm talking in vague terms because I didn't want to write code. So damn it, I painted myself into a little conversational corner. We have bool, compare, call number. Title, subjects, and other. This one is virtual. We have a display function, and we have a destructor. Let me see, am I missing anything in the public interface there? think that's about it. So, that application programmer comes along and wants to create the DVD type. So I want you to weigh in on lines 13 and 14. Separately. Take them as individual cases. And what I specifically am honing in on is that this application programmer is going to write their own compare call number function for DVD, and they're going to write their own compare other function for DVD. Now, if you, now being a senior vice president of library conglomerates, you're paying a visit to the lowly library branch here, and you pass by the screen of this developer, and you see this up there, basically lines 7 through 15, or excuse me, 11 through 15. How would you counsel that developer as to the wisdom of line 13 and as to the wisdom of line 14? You don't want to put virtual before what?
You want to put virtual before 14 because it's going to be called a DVD.
I don't want to put virtual before. Well, so the keyword's optional here. I can do that. It's still a virtual function. Yeah.
Call number is not virtual in the media class, so they can't just write their own function.
I think that yes, that's exactly the observation I'm looking for, is that compare call number isn't virtual, which means if I have a DVD object, or the address of a DVD object assigned to a media pointer, the decision as to which function to call is made at compile time, right? So keep in mind that all this business of virtual and the virtual jump table and all that stuff gives us the luxury of the code not knowing what object it's pointing at, and while the program is running, the decision is made as to which function to call. If the function isn't virtual, there is no entry in this virtual jump table, and the decision is made while the program is compiling. And while the program is compiling, the only information the compiler has to go on line 19 is that MP is a media object, so it is going to bind the function that is declared on line 3 to that function call, right? So it's an interesting side effect that we went through a process of deciding what functions were virtual and what weren't through our design process. We went, okay, these functions here have a common interface and a common implementation. We're going to abstract both the interface and the implementation of that function up, meaning compare call number, and there's nothing left in the derived classes, whereas with compare other, the interface is the same between all the derived classes, but the implementation was different. So what we do is we just draw up the interface and tack the word virtual in front of it. So that process has a nice side effect, which it is kind of a documentation looking back at the class declaration, meaning lines 1 through 9, in that we can look at that and glean the intentions of the designer. The intention is that you may need custom behavior for these functions we've labeled virtual. Feel free to write your own version of those virtual functions. Whereas if it isn't virtual, that means the behavior is meant only to be in the base class, and you should not be writing your own functionality in the derived class for those functions. Okay. So this is a long way around of saying that this becomes part of the stamping press project when I said we're going to get into the internals of the O stream and its related classes, in that we're going to have to examine documentation that you can find at like c++.com or any of those other reference sites. And you're going to have to look at these interfaces for O stream and those classes and decide what did they want us to write our own versions of and what did they want us to leave alone. All right? So that's going to be a key activity that we'll be doing in this upcoming project. Let's look at a bit more detail of what the project context is. So there are a number of files here that you can download. I don't know why I didn't just create a tarball, but oh well. There's a PDF here. Let me bring the PDF up. It's a title page. Here's a bit of marketing literature that I'll let you read on your own. The idea is that there's this press that takes plates of metal or maybe like thick aluminum or something like that, and that this press has kind of a robotic arm that will go out and grab a die, like a die of a letter A, and then it will come over to this plate and it'll stamp the A down, and then if it needs a letter X, it'll go put the A down and grab the X, and then at some other two-dimensional XY location will stamp the X. I don't know if the damn things exist, right? It's just kind of the pretend kiosk in the pretend mall. And so people come and they get their world's best dad, I don't know, serving tray, right, stamped in there so deeply that if you put any little glass on it, it kind of tips into the divots created by the stamp. But I'm getting ahead of myself. The kiosk owner will buy this physical piece of hardware. And coming with that hardware is a software library for interacting with the hardware. And so you can have your applications developer develop an application to program the stamping press to do things. And the interface is simply a set of C functions. Now, I've thrown a namespace around here, so it's kind of living in the C++ world, but these are very much C functions. There's nothing object-oriented about these functions at all. And there's a description for each. Set die is when you call this function and you give it a letter like the letter A, this is the function that you call to have the arm go and pick up that particular letter. Okay. Get die is a command that allows you to interrogate and say what die do you currently have in your robot arm. Insert plate is the equivalent of taking this sheet of aluminum and putting it into the machine. You provide the dimensions of the plate. There's an eject plate, so when you're done, you call this function and it kicks it out of the machine. And then kind of the function that does all the work is the stamp function. You give it a particular X and Y location, and it will, whatever die is currently in the robot arm, it'll stamp down at the location specified. You'll note that there are, if you read through this, there are actually some exceptions that are thrown. So, for instance, there's a limited number of dies available. It says here the upper and lowercase letters, digits, and the pound sign and the asterisk character. So, for instance, the double quote character, well, let me think of a different, what would be, but the @ sign. If I call this function and I pass in the @ sign, it will throw an exception, an invalid argument exception, because no die exists. It will also, if you read this, it will also throw an exception if you ask it to set the die that is already set in the machine. So if I say set die A, it grabs the A, and then if at some point in the future, while it's still holding the A, I say set die A, it'll throw an exception for that reason because it already has it. Get die, self-explanatory. Insert plate, it's going to throw an exception if you've already inserted a plate. Eject plate, it'll throw an exception if you've already ejected the plate. I mean, there's no plate in there. And then stamping will throw an exception If there's no plate in there, or if there's no die in the stamping arm, or if you provide an X and a Y value that's out of range of the dimensions of the plate that you provided. Pretty straightforward. We can go ahead and write a little test program. So here are all the, I grabbed the files that are on that assignment description. Let's look at stamp.h. This is, I mean, it's exactly what we saw in the PDF write-up, right? It's just a header file that has function prototypes in it. Exactly what we'd expect. Stamp.c, you're welcome to look at it. This would normally, stamp.cpp, excuse me. This would normally, from a vendor, would be a compiled binary, a library, right? You wouldn't normally have access to the vendor's code, although in this day and age we have more and more open source benefits, I guess, the way the culture is going, the software engineering culture. But the traditional model is the vendor gives you a binary of the interface to their device. So this, you're welcome to look at it. It's just code I wrote to simulate a stamping press, since I don't have one to bring in to lend to you, much less half a dozen of them. Okay. So this is my stamping press simulator. We would write a program. Let's call this Stampy. I'm going to grab my little 111 template here. We need to pound include stamp.h. And again, everything's in this stamping press namespace. So I need to, for all these, I would have to say stamping press : set die, so that I can avoid doing that. I'm just going to say using namespace stamping press. I'm going to insert a plate. We'll make this plate 10 by 10. We will set die, how about the letter A? Stamp. And we'll create like a diagonal. Let's go ahead and set another die, set die. Let's do the pound sign. And let me borrow these lines. And I will stamp them at, come on, stagger it a little bit. And then we eject the plate. So let's go ahead and compile that and run it. We have to say G++. Stampy.cpp. You also need that source code to that library. Run it. There's our simulated plate, which comes spitting out when you call eject plate. What homeowner wouldn't be proud to have that, huh? You can, you're welcome to stamp over somewhere you've stamped, and the behavior is it just overrides, so you can think of just the metal being reformed for the new letter. So if I, maybe I'll come down here and say set die, and I'll give it a, I don't know, a P, and then I'll restamp at that like 3.3 location that I did on line 13. Come over here and compile, run, and then you can see the P overwrote where the A had been. So that's what our starting point is. In our assignment is to make this thing work like cout. So here's some sample code. In fact, I have a copy of that sample code in the handouts, dim main from pdf.cpp. I learned the hard way to provide this file here because I had a couple semesters where students took this and they did this. They copied that and then they pasted it into a CPP file. And if you look, this is a smart quote right here, and that created hours of debugging for them. So I learned my lesson. Don't copy and paste that. Grab this version here. How does it work? Just like you create an OF stream to create a file, you create a stamp stream. Give it a name, doesn't matter what you call it. Here the plate's 30 by 10. Here we're printing a bunch of stuff. So note that it handles strings, handles floats, handle integers, it'll handle everything, right? We have a couple functions like this one here. End row is kind of like end line. That'll bring you to the beginning of the next line. Also, you can specify a row that you want to jump to. So that's what those are doing. We can look at the sample output here, coming back to this. Let's see if I can get that code next to, how's this going to work? If I minimize that, there we go. Okay, that's pretty close. So we start printing, it starts in the upper left-hand corner, spitting this stuff out. We have an end row, and then house all the fish. So then that comes down. You'll note there are a couple spaces before house. So that's shown there. Note that rather than this thing, again, there's no single quote in the stamping dies that are available. So the behavior you should do is not to have the thing freak out, is you just simply have a space print. Or in other words, it's all start spaces, print nothing at that location if there's a die requested that doesn't exist. Darn it. Also, so we have the period in the 3.14, the period doesn't exist, so that's why that's blank there. And you'll notice that if you type something really long, then it just simply ceases printing after the end there. Rather than, again, a lot of these things in the original functions throw exceptions, right? So we have to do some exception catching, or either that or some intelligent processing to avoid the exceptions from being thrown. So that's what our task is. There are a couple things that I want you to look up prior to Wednesday. To-do.txt. One is read up on conversion operators. 2, read up on conversion constructors. And I'm not looking for you to produce anything that you give to me. You could all give me the thumbs up and say that you did it and not do it, but it'll make life a little bit easier for all concerned if you've at least spent 5 to 10 minutes on each of these to figure out what they are. Okay, that'll make Wednesday easier. Any questions? All right, so like I said, looking at this last year, I kind of went short, so I'm going short. If there aren't any questions, then the 25 minutes remaining would be a fantastic time to look at those two items, the conversion constructor and the conversion operator. Then you don't have to do anything once you leave this room until Wednesday. Okay? All right.